if we're using phasors to represent our fields, to represent our waves, then we can simply add the two vectors together, the two phasors together. Keep in mind that vectors only have two pieces of information, which is how much and which way. What that means is the actual location of the vector doesn't matter, so we're free to pick our vectors up and move them around. And so let's say that we have two waves, a1 sine k1x and then a2 sine k2x plus phi 2. So what we can do, if we want to figure out what the superposition of these two is, what is y1 plus y2, one way to go about representing this is by adding two phasors together. And so here in red, I have the phasor representing y1. And then remember, with vector addition, if we're doing things graphically, we lay the vectors out tip to tail. So if I'm adding y1 and y2, then I'm going to place the tail of y2 on the tip of y1. And then the sum of those two is what I get from going from the tail of the first vector to the tip of the last vector. So in other words, this purple line represents my angle, or my final field, my superposition of the two. So the angle that y1 makes with respect to horizontal is k1x, and the phase angle of phasor corresponding to y2, well, this is the phase angle right there, it's simply this. Notice that I've made this with respect to horizontal, and so I've created a little dotted line in the horizontal direction parallel to the x-axis, and that's how we measure my angle. Now, if we actually want to calculate the length of the field, the result of the field, we need to do just a little bit of geometry. And so if we just focus in on this part of the graph right here, I've kind of drawn it over here, and this angle in here is essentially this result right here. And so you can see that this is my original k2x plus phi 2. This then corresponds to k1x. And so then this inner angle here is simply this guy right here, which means to get this angle in here, which corresponds to alpha over here, I simply have to take pi minus this result. And so now I have this angle, which means I can use my law of cosines to figure out what the amplitude of y1 minus y2 is. And so just a quick reminder, here's what we have for the law of cosines. It says that if you have a triangle whose sides are A, B, C, and you know one of the angles that's immediately across from an unknown length, you can solve for that using this. It's very similar to the Pythagorean theorem. The primary difference is you have this minus 2ab cosine theta. So if we want to figure out what the amplitude of the two fields added together using phasors, well, we simply use the law of cosines and then take the square root. Because remember, we're getting c squared over here. What I actually want is c, which corresponds to that right there. And so then we have the superposition of two waves.